Good morning to all present over here. So today what we are going to see about the topic Abdina, we are going to see about an synchro. Okay. So when we are saying about an synchro, actually it is a type of transducer which transforms the angular position of the shaft into an electric signal. It is used as an error detector and it is used as a rotary position sensor. Okay. The error occurs in system because of the misalignment of the shaft. The transmitter and the control transformer are the two main parts of the synchro. So when you are saying about an synchro system types, actually we'll have two different types. One to be the control type synchro, the other one to be the torque transmission type synchro. So when you are saying about an torque transmission type synchros, actually this type of synchros has a small output torque and hence they are used for running the very load like a pointer. And similarly, when you are saying about an control type synchro, actually it is used for driving the large loads. So when we are saying about an control type synchro system, actually the control synchros is used for error detection in positional control system. So the systems will consist of two parts. They are to be named as an synchro transmitter and synchro receiver. So when you are saying about an synchro, actually it always work with these two parts. Okay. So the detailed explanations will be given as it is. So we have to explain what is synchro transmitter and synchro receiver. So when you are saying about an synchro transmitter, actually the construction is this is the construction. This the construction is similar to three-phase alternator. The stator of the synchros is made up of steel for reducing the iron losses. The stator is slotted for housing the three-phase windings. So when we are saying about an axis, the axis of the stator winding is kept 120 degree apart from each other. So when you are saying about an AC voltage, actually it is applied to the rotor of the transmitter and it is expressed as an root 2 of sine omega CT. So where VR stands for an RMS value of the rotor voltage and omega C stands for an carrier frequency and T for an time period, we know that. So when you are saying about an coils, actually the coils of the stator windings are connected in star. The rotor of the synchros is in a dumbbell in shape and a concentric coil is wound on it. Okay. The AC voltage is applied to the rotor with the help of a slip rings. Okay. So this is the constructional feature of the synchros. Okay. And this is there is a synchro transmitter and the diagram this shows for an synchro error detector. So thing is to be that we have to consider the voltage which is applied to the rotor of the transmitter. The voltage applied to the rotor which induces the magnetizing current and an alternating flux along its axis. Okay, the voltage is induced in the stator winding because of the mutual induction between the rotor and the stator flux. The flux linked in the stator winding is equal to the cosine of the angle between the rotor and the stator. So where the voltage is induced in the stator winding. Okay. So when you are saying about tan, we will be considered as an that is the VS1, VS2, VS3. There are the voltages generated in the stator windings S1, S2 up to S3 respectively. Okay. So when you are saying about tan, the rotor position of transmitter, the rotor axis will make an angle theta r connecting the stator windings S2. So we can use the expression that KVR sine omega CT cos of theta r plus 120 degree. And similarly, S2 will be giving us an KVR sine omega CT cos of theta r. Okay. And when we are saying about over on it, so we'll have a KVR sine omega CT cos of theta r plus 240 degree. Okay. And when we are saying about tan VS1 with the other terminals of the three terminal theta windings, which is given as an VS1 S2 is equivalent to VS1 n minus Vs2n. Okay. So Vs1 S2 will be equivalent to root 3 of k into Vr sine of theta r plus 240 degree sine omega ct. Where S3 S2 is equivalent to S2n minus S3n. Similarly, when we are replacing for the value of an S1 S2, which is equivalent to root 3 kVr sine of theta r plus 120 degree sine omega ct. Whereas S3 S1 is equivalent to S3n minus S1n. So the value will be equivalent to kVr sine omega ct into sine theta r. Okay. The variations in the stator terminal connecting the rotors which can be given as an E of t, that is equivalent to k dash of VR of sine of theta r minus theta c of sine omega ct. When the rotor angle becomes 0, the maximum current is produced in the stator windings S2. The zero position of the rotor is used as a reference for determining the